Hello students, now we will go for the circular waveguides. So the circular waveguide which will perform the same function as a rectangular waveguides. Similarly, the wave propagated in circular waveguide will be propagated in similar wave as in rectangular waveguides. Means in rectangular waveguide the wave propagated in the particular direction will be same as in circular waveguides. So if you look to the structure of circular waveguide, so this is just a metallic pipe of a circular cross section used as a waveguides is known as a circular waveguides. So this is a circular like structure is there which has also an internal wall and the wave will be propagated inside the circular waveguides. So microwave wave will be propagated. So it propagates both vertically and horizontally in polarized wave in the same waveguides. So polarization will be for both vertical and horizontal. So in construction you will see the wave travel in same manner as they do in rectangular waveguides. So wave will be travel here. All the definition parameter used for rectangular waveguides must be same as for the circular waveguides. So definition and all this one will be same as a rectangular and circular will be same. Okay. So here we will see the cutoff frequency of a circular waveguide. So here we have the lambda 0, that is the cutoff wavelength of a circular waveguide, that must be equal to 2 pi r divided by kr. So we will see what is lambda 0. Lambda 0 is a cutoff frequency. R is what? The R is basically a radius of a circular waveguides. So it will be look like, and this is a radius R. Okay, which has also a diameter, and this kr is basically a one function is there. That function is called Bessel function of waveguides. So after the definitions and the cutoff wavelength of circular waveguides, we will go for the field patterns of circular waveguides. Same manner as that of rectangular waveguides. So in field patterns, we will go for the T11 modes and T01 modes. So here I will show you the figure. So if you look to the figures here, so you will just check it. This particular what will say, the vertical lines will be represented by electric fields, and this will be representation of what? The magnetic fields. So here both the fields are what we will say the perpendicular to each others. Similarly here, if you see, these dotted lines will be the magnetic fields, and this particular what will say horizontal or cross sectional line is the electric fields. So electric fields are, this will be represented by the solid lines, while that should magnetic fields will be represented by dotted lines are there. So if you go for this one, the both the fields are perpendicular to each other. So these are the modes of propagation for T11 mode and TM0 modes. So you just remember, this is the field pattern of circular waveguides. Now we will go for the advantage, disadvantage and application of circular waveguides. So the it will be same as what will say rectangular waveguides. So advantage, so the advantage is what? It is easier to manufacture, then it can easily join, then it propagate both vertical and horizontal. Vertical and horizontal polar propagations will be achieved through circular waveguides. Similarly, what will be the disadvantage? The disadvantage is what? That cross-sectional area is there. This one is a circular circle. This cross-sectional area is much more bigger as compared to rectangular waveguides. Similarly, the phase will be there. If wave will be transmitted like this, the phase will be drastically changes. So the applications, in applications we will see it is used in microwave, satellite, radar. Principle, it will be also used for the rotational joints, means if you join the two more components of microwave, we have to use the circular waveguides. Now the last is what we will compare waveguide with transmission line. That should be the important parts, waveguides with transmission lines. So here total 6 points we have to cover. So what is waveguides? And what is transmission lines? So in transmission line we have alpha, beta, gamma. These are the secondary line constants, while primary line constant is R, L, C and G is there. Okay, so in waveguides there are different modes are there, like TE mode, TM mode, TEM mode. It has a phase velocity, then group velocity. Okay, so what will be the definition of waveguides and transmission line? Waveguide is just like a hollow tubes are there, which will be basically used to propagate what? The microwave energy signals. Okay, so this is a rectangular waveguides. Transmission line is basically a what? It is a conductor or wire where RLCG components are connected. So these are the structure of transmission line. Here L, R, C, G, like this one. So here we have to transmit the microwave signals. So this is a conducting wires where the signal will be transmitted. So it will be operated in T or TM modes. Here it will be operated in TEM mode or quasi-TEM modes. Similarly, it is where it will be used radar, satellites, micro signals. Transmission line basically used for the TV signal transmissions. Okay, so here we have the, here waveguides has a large size, cost is more. Here size is large but cost is less. It will be operate at a higher frequency. Waveguide will operate at a higher frequency, while that of transmission line there will be no cutoff frequency for TM mode, so it can transmit signal to high frequency also. So here we have TE or TM mode, here we have TEM mode. Cost is more, size is more, so it is a circular or elliptical or rectangular waveguide. Transmission line, again there are the different components are there, that is RLCG, primary line constant, and alpha, beta, gamma, that is a secondary line constant. So in comment you should mention the difference between waveguide and transmission line. Okay, thank you.